Here's the solutions video to the other review sheet, or if this is the first one you're watching, to the first review sheet. So let's get started. Simplify. So we are simplifying that radical. We're looking for groups of 4, so let's break down 486. If you break it down, you should get 3 times 3 times 3 times 3 times 3 times 2. Okay, so and I'm looking for groups of 4, and there's a group of 4. So I can pull out 1 3. Now I still have this 1/3 out there, so I'm pulling out a 3. And I can pull out 2 groups of x's, and I can pull out 1 group of y's. And still under my radicals, whatever I didn't pull out. I still have this 3 and this 2 under there, so I still have a 6 underneath. I pulled out all the x's, but when I pulled out the 1 group of y's, I still had 3 y's left under there. And out here, remember 1/3 times 3 is just 1. So your final answer is just going to be x squared y times the 4th root of 6. What is up with my pen? 6y cubed. B, I'm not even going to do. You need to know the quadratic formula. If you don't know it, look it up. For C, we want to know which quadrant 882 terminates in. All right, remember, if it's too big, we want to have everything between 0 and 360. If it's too big, we keep subtracting 360s until we are between 0 and 360. You have to subtract a few times, but 882 terminates in the same place as 162 degrees, and 162 degrees is in quadrant 2. All right, remember, if this is our quadrant plane, we start up here and we go counterclockwise, so there's 1, 2, 3, and 4. For D, it's very similar to C, except I'm negative, which means I'm way smaller than I need to be. So instead of subtracting 360s, I'm going to add 360s until I'm between 0 and 360. And when you do that, you should get 233 degrees. All right? Coterminal means they end in the same place. So 200 going positive 233 degrees ends in the same place as if you had went negative 487 degrees. Write the radical in exponential form. Radicals are fractional exponents. So since this is the 4th root, this is the same thing as if 3x was raised to the 1/4 power. Okay, I talked about this. Remember, if you take a fractional exponent and you knock it over, that's how you get this radical. So if I knock this 1/4 over, the 1 would fall on the inside, which is why that is just 3x to the 1st power, and the 4 would stay on the outside, which is why your index is 4. So I'll write that on the line. 3x, and all of that is to the 1/4 power. If you write this, you're saying just the x is under the radical, so it's not this. You need the parentheses. For F, here they give us the fraction and we need to knock it over. Okay, so the 8 does not have the exponent, so the 8 stays 8. And then when you knock that fractional exponent over, the 3 falls on the inside and the 4 stays on the outside. So this is 8 times the 4th root of x cubed. And G, we need to simplify, looking for the cube root of 64. If you break down 64, that is going to be 2 times 2 times 2 times 2 times 2 times 2, and then 5 is just 5. Here's a group of 3, here's a group of 3. So I pulled out 1 group, I pulled out 2 groups, so I have 2 2s on the outside, and then I'm left with 1/5 on the inside. The 5 has to stay in the denominator, so your final answer should be 4 times the cube root of 1/5. Number 2, we had to solve and check. All right, we always have to check for extraneous roots. Before I can go ahead and square both sides, I need to get the radical isolated. So let's subtract 4. And now I can square. Horrible too. So here I just have 2x minus 5, but on the left, remember x minus 4, when you square that, you're going to have to FOIL, or do the box, or whatever you want. When you do that, you get x squared minus 8x plus 16. And now we have a quadratic, so let's get that equal to 0, so we can either factor or use the quadratic formula. So I'll subtract 2x, add 5 to both sides, so you get x squared minus 10x plus 21 is equal to 0. And this does factor into x minus 3 and x minus 7. The zero product property says that this means that x minus 3 equals 0 or x minus 7 equals 0. So x equals 3 or x equals 7. But no, I am not done because you need to check. And whenever we check in the original. So that is what we are checking in. I'll check 3 first. So I get 3 is equal to 4 plus the square root of 2 times 3 minus 5. That turns into the square root of 6 minus 5, which turns into the square root of 1. So this is 4 plus 1, so I get that 3 is equal to 5, which is not true. So x equals 3 does not work. We have to reject it. It is an extraneous root. And then I have to go ahead and check 7, so I get 7 is equal to 4 plus the square root of 2 times 7 minus 5. That's going to become 14 minus 5. And 14 minus 5 is 9. And the square root of 9 is 3. And boom, baby, 7 equals 7. So 7 worked. All right, so we had to reject x is equal to negative 3 because it was extraneous. The check didn't work, but 7 is bueno. On to the back. Solve for x and check. Notice we have a lot of checks going on in this. Sorry about that. So I have an equation. Equations, we eliminate the denominators. So how about I factor my denominators and see what I'm working with? So this is going to turn into x minus 3 over, here's a GCF of 6. So you pull out the 6, you're left with x minus 12, or x minus 2. Plus, this is the difference of perfect square. Why is this right here? Can I move this? Ah! Whatever. This is the difference of perfect squares. It factors into x minus 2 times x plus 2. And then over here, there's a GCF of 2, and you are left with x squared minus 4. But x squared minus 4 is the difference of perfect squares, so that factors again into 2, and then I've got now x minus 2, x plus 2. So now that I have all my factors, I can go ahead and start eliminating. All right, maybe you picked something different. So your work might look a little different than mine if you chose to eliminate in a different order, but we should still get the same answer. I am going to eliminate x plus 2's first. So I'll multiply here by x plus 2, multiply here by x plus 2, and I'll multiply here by x plus 2. Which is awesome because bam, bam, those cancel. Now, in this first term, though, it doesn't. And you need to be careful because this is all of x minus 3 times x plus 2. All right, so some foiling is going to happen at some point in time. And then for my second term, I have x minus 1 over x minus 2. Those cancel. And then here, I've got 4, and then I have 2x minus 2. I don't know what is going on with these equal signs. Now I'm going to go ahead and eliminate all of my x plus 2. So that's what I picked next. So I'm going to multiply everything by x minus 2. And bam, bam, bam. That was nice. So now I'm going to be left with x minus 3 times x plus 2. Still over 6. Plus, now I just have x minus 1. And now I've got 4 over 2. But 4 divided by 2 is just 2. And now I'm almost done. I have one thing that I still need to eliminate, which is the 6. So I multiply here by 6. You need to multiply everything by 6. So this gets multiplied by 6. This gets multiplied by 6. And you can do this 2 ways. You can multiply each of these by 6, or you could have wrote it with the parentheses and then distributed. Either way, you should still get x minus 3 times x plus 2 plus 6x minus 6 equals 12. And now I will come over here. And now I need to FOIL that little bit on the left. When you FOIL that, you're going to get x squared minus x minus 6. And then I have all that stuff left. So plus 6x minus 6 equals 12. We have a quadratic, so the way to solve quadratics is to get them equal to 0 and then factor or use the quadratic formula. So I just got to subtract that 12 over, combine some like terms. So I'm going to have x squared. Combine these, that's plus 5x. Minus 6 plus minus 6 is negative 12, plus I subtract that other 24, so that, or that other 12, so I get minus 24 is equal to 0. Things that multiply to give you to negative 24 and to give you positive 5, that is going to be x plus 8, x minus 3. Zero product property means that x plus 8 equals 0, or x minus 3 equals 0. So x is equal to negative 8, or x is equal to positive 3. But we are not done because we need to check for extraneous roots, and whenever we check in the original. And let's see, do I want to check this? Do I want to go through the bother? I will leave that to you guys just for space reasons. All right, but you need to plug this into the original. So, for example, when you check x is negative 8, this is negative 8 minus 3 over 6 times negative 8 minus 12, plus you've got negative 8 minus 1 over negative 8 squared minus 4 is equal to 4 over 2 times negative 8 squared minus 8. And you got to work all that out. You need to have the check to get full credit for the question. So if you need to do this on separate paper, go ahead. I have a smartboard. I don't have separate paper. All right, let's move on to, how many questions we got left? 2. All right. Absolute value. Absolute value, there are 2 cases. There's the positive case, there's the negative case. So I've got the case that 4 minus x is equal to 10 plus 2x. Or I have the case that 4 minus x is equal to negative 10 minus 2x. You change the sign of everything. Let's solve for x. I've got 4 is equal to 10 plus 3x. Subtract, you get negative 6 is equal to 3x, so x is equal to negative 2. Or, let's see, we've got 4 plus x, I added the 2x to both sides, is equal to negative 10. So then I get x is equal to negative 14. Sounds about right. Making sure, double checking. And I'm not done because I still need to check, and we check in the original. So I will check x is equal to -2 first. So I have the absolute value of 4 minus -2, which is equal to 10 plus 2 times -2. This becomes the absolute value of 6. This becomes 10 plus -4, or 10 minus 4. And I get that 6 is equal to 6, so that checks. When I check x is equal to -14, that's going to be the absolute value of 4 minus -14, which is equal to 10 plus 2 times -14. Here, this is going to become the absolute value of 18. And the absolute value of 18 is 18. And over here, I get -18. So this does not work. This positive 18 does not equal -18, so we need to reject. Alright, x equals -14 is an extraneous solution. On to number 5, we are combining. Okay, this is not an equation where we eliminate. This is not complex where we cancel. Here we're just shoving stuff together. Alright, so I need to get some common denominators. But before I do that, how about I factor and see what I'm working with? There's a GCF in the first one. You can pull out an x and you're left with x minus 5. And the second one is the difference perfect square. So it's x minus 5 times x plus 5. The smallest thing that has all of the denominator factors multiplied together, aka your least common denominator, is going to be x times x minus 5 times x plus 5. The smallest thing that all three of these multiply together to. So now let's look. What am I going to multiply this one by so the denominator has all three of these things? Well, it's already got the x and the x minus 5. It just needs the x plus 5. So I'm going to multiply top and bottom by x plus 5. So when I do that, I'm just really multiplying by 1, so I'm just changing how this looks. I'm not changing what it's equal to. When I look at this term, it's already got the x minus 5 and the x plus 5, it's just missing the x. So I'm going to multiply top and bottom by x. And it looks a little messy, but now both of these denominators have x minus 5 and x plus 5, so I can smush these together. And in my numerator, now be careful, because you need to FOIL the left part. And this negative, no, that's just -4x, that's nothing fancy. When I FOIL, I'm going to get x squared plus 2x minus 15. And now I still have this plus -4x tacked on the end. And now with my numerator, I have some like terms that I can combine, right? Because I've got a 2x and a -4x. So this becomes x squared minus 2x minus 15. Still all over this stuff. And then we look at my favorite thing, the numerator factors. This factors into x minus 5 and x plus 3, which we should all be super happy about because now I have an x minus 5 in the numerator and the denominator. So, cancel town. So now I'm left with an x plus 3 in the numerator and an x times x plus 5, if I could write, in the denominator, and now we are done-zo.